Hello everyone. In this video, we are going to study Class B amplifier, its operation, advantages, disadvantages and also applications. So let us start. Class B amplifier uses two complementary transistors to amplify each half of the output. One transistor conducts for only one half of the signal, while the other conducts for the other or opposite half of the signal waveform. Each transistor spends half of its time in the active region and half its time in the cutoff region, thereby amplifying only 50% of input signal in one half. The transistor only conducts when the input signal is greater than the base emitter voltage. And for silicon transistor, this is about 0.7 volt. Therefore, with zero input signal, there is zero output. So this is the small introduction of Class B amplifier. Let us see the operation of Class B amplifier and its operation curve. So here we can observe we are using two transistors, and here when one will conduct, other will not, and when other will conduct, this will not. So it is also called as a push-pull, means one is pushed and another is pull. So it is also called as push-pull amplifier. So let us see how it actually works. When we apply this input over here, so first the input signal goes positive. The positive biased transistor conducts, while the negative biased will be switch off. Likewise, when the input signal goes negative, this is the positive half. So for the positive half, one of the transistor will conduct, and for this is the negative half. For the another negative half, the another transistor will on. So when this is on, this will get off, and when this will get on, this will get off. So the transistor conducts only half of the time, either on the positive or negative half cycle of the input signal. And since no DC voltage is biased to the transistor, the output transistors to start conduct each half of the waveform. Both positive and negative, they need the base emitter voltage. They need base emitter voltage. Okay, this base emitter voltage they require, and this base emitter voltage must be greater than 0.7 volt forward voltage drop required for the standard bipolar transistor. For silicon it is 0.7 volt, no? So that's why its minimum requirement of voltage is 0.7 volt to conduct any of this transistor. Thus, the lower part, this is the upper part, this is the lower part of this output waveform, which is below 0.7, will not reproduce accurately. This results in a distorted area of output waveform as one transistor turns off, waiting for the other to turn back on. Okay. So the result is that a small part of output waveform at the zero voltage crossover point, which will give the cross distorted or will get the distortion. See what's actually happening. for one half this is conducting and for another half this is conducting. Means some at 0 voltage at some point, at the moment that it stopped working, at the right at that another moment it's not switching on. So that lag time in between, that will give the distortion, and this type of distortion is called crossover distortion. So this is the only problem with this B class B amplifier, that the cross distortion occurs, crossover distortion. So let us see the operating curve. See, in each transistor only one conduct through one half or 180 degree, this much. But as the output stage has device for both halves of the signal waveform, the two halves are combined to produce a full linear output waveform. And the Q point of this class B amplifier is present at cutoff region, that is on x-axis. This is the x-axis, this is the cutoff point. Thus, the transistor will remain off when there is no AC input signal applied. And the coordinates of this Q point is VCC 0. And the efficiency of class B amplifier is more than 70%, and it is around 78.5%. And this push-pull design of amplifier is quite efficient than the class A amplifier. The only issue is it has crossover distortion. Now let us see the advantages. Some amount of distortion in the circuit gives the more output per device because of there is no presence of even harmonics. The use of push-pull system in class B amplifier eliminates the even harmonics. Some disadvantages also there. So in class B amplifier, there is high harmonic distortion and there is no need for self-bias. Some applications are low cost design. This amplifier is more significant than class A amplifier. Class B amplifiers suffers from a bad distortion if the signal level is low. So these are some of the applications. So with this I stop here. Thank you.